This conference will now be recorded.
So we completed a discussion on geographical maps and background images and dashboards and stories. All this is done. So we are going to focus on calculations today and tomorrow. The next two modules are on calculations in Tableau. Okay. So this is not new to us, right? We have already created a few calculated fields in our training. We have seen case statement when we did background images, and we have seen some simple logical statements like how do you put an if else if condition kind of a thing. Okay, so here we will be looking at all of them a little more in detail. We'll be looking at a few more examples with respect to calculations. So to begin with, we will discuss what is a calculated field and how to create it. So what is a calculated field? Is basically when you have the data, that is all the data necessary. You have the necessary data, but it may not be sufficient for your analysis. Okay, then you can manipulate that data by writing a few formulae, and that is nothing but a calculated field, right? And Tableau has a lot of inbuilt functions. We saw that it provides a lot of support even to a person who is absolutely new to this concept of writing a formula. It does not matter because Tableau will not just give you the name of the function, it will give you the syntax along with a detailed explanation of what the function does, and also it will give you an example of how you use it. Okay, the syntax and example. So with so much support given to us by Tableau, it is nearly impossible to go wrong with respect to the syntax of the calculation. With respect to syntax, now how will you do with the logic depends on how well you perform. Now, how well you analyze your problem statement and how well you frame a formula for that problem statement. So arithmetic calculations which will help us manipulate numerical data. We have string calculations which will help us manipulate string data, date calculations for date manipulation, logical functions to write any logic kind of thing. So let's say I want to compute profit ratio. Okay, so I'll get connected to sample superstore. Okay, now I have profit data with me. Profit is a field that is present in my data source. Sales is a field that is present in my data source. Now what do I need to do? I need to compute profit ratio, which ideally is computed as summation of profit divided by summation of sales. Okay, so given profit and given sales, to compute profit ratio, which is not there in the data connection, I'll have to create a calculated field. How do we create a calculated field? We go to the analysis option on the menu and choose the option to create calculated field. Once you select that, we know that we can give a name to our calculation over here. We know that we can type in the formula in this section. So sum of profit divided by sum of sales. Okay. And here we have a lot of inbuilt functions which are there in Tableau, which will help us with writing the calculations, right? And they're also segregated into different types like numeric functions, string functions, date functions, type conversion, logical, aggregate, all these user functions, etc. All right. Now, sum of profit divided by sum of sales. It's just an expression, a mathematical calculation where I'm using the division operator. I'm going to divide profit by sales. So I'm just using a division operator here, not using any function as such, but I'm just using a division operator. So once I click on OK, Tableau will compute sum of sales and sum of profit. At what level should it compute? We have not yet defined anything on the graph, right? So what we will do is let us look at profit. And let us look at sales, and this is the profit ratio. Okay, this is the profit ratio. So the profit, and then you divide it by sales, we're getting profit ratio as 12.4%. You can see that, or 0.1247. Now you will notice that profit ratio basically has something called as AGG. Profit ratio has something called as AGG. AGG stands for aggregation. AGG means that the data has already been aggregated and you cannot further aggregate it. Means what? What is the result of that calculation? Is it multiple values or a single value? It is taking summation of profit, this one number, dividing it with sum of sales, another number, and giving you this value, which is one single number, right? How we cannot further aggregate this anymore. We cannot further aggregate this. Therefore, that is where your profit ratio will lie. Now, suppose I use region and break my data, granularize my data. Then what's happening? Tableau is showing us sum of profit per region, sum of sales per region, and the profit ratio, which is 39,706 divided by 501,240, giving you so and so value. All right. So what is happening here is we are first aggregating the data, computing sum of sales and sum of profit, depending on the dimensions that are there on the graph, depending on the level of detail on your chart, depending on how you have granularized your data using the dimensions, and then dividing these two numbers, giving you another number. So obviously it cannot be further aggregated. It is already aggregated. Okay. So this is like a table scope calculation, you can call it, because here we are performing everything depending on how the chart is built. On the other hand, here it is not relevant, but I'll just take you through the concept. Sometimes it may be required to perform the computation first. So I'll just do profit divided by sales. Profit divided by sales. Okay. Now at what level this gets computed is, you will see a completely different set of values for profit ratio. Okay, why? Because what is happening here? Did we aggregate it inside the formula? We did not aggregate it inside the formula. I just did profit by sales. So what Tableau will do is it will compute profit divided by sales is something that it will do at row level. Even here it is doing at row level, but ultimately it is computing depending on the granularity of the chart. Here what it is doing is profit divided by sales is getting computed, no? Profit divided by sales is getting computed. And then what is happening? This data is being aggregated using summation. These values are being summed up. Okay. So what Tableau did is first, it is computing profit divided by sales, and then it is summing up this values because we are using summation as the aggregation. It is summing up this data for every region, per region. So profit is there, sales is there, profit divided by sales is computed. After that, for each region, let us say central region, Tableau has summed up the data present in this column, and the summation is coming up to be a negative value. You can see on the taskbar at the bottom, minus 241.76. Minus 241.76 rounded off to minus 241.8. Okay. So when you do not give any aggregation inside the formula, whatever is computed at row level, that will be taken, and then it will be aggregated depending on whatever dimensions you are using on the graph. If I don't use anything, then that is the summation of the entire data present in the profit ratio column that is computed at row level. Summation of the entire thing is, you can see averages 1203. 12 rounded off, let us say. You're getting its summation of the entire data. Now, when I take region, it is getting broken down at region level. It is getting broken down at region level. Is this clear? What happened with the first formula? Can you tell me? What happened with the first formula where we did sum of profit by sum of sales? First aggregation happened, means Tableau computed sum of profit for each region. Then it computed sum of sales for each region. Then it divided this value by this value. Agreed? First profit ratio. In the second profit ratio, what happened? We did not give any aggregation. So it is just doing profit by sales for every record in the database. And then it is summing up for each region. The data that came as the result of profit divided by sales, that was summed up at region level. Is this clear? So different ways in which you can write your formula. You can have a row level calculation. You can have a table scope calculation also. Table scope means it's working on the data in your chart. As simple as that. All right. So this was a mathematical calculation. Now let us look at a string calculation. I'm just giving you a demonstration. Then we will do the hands-on. I mean, you will do the hands-on. String starts with S. So let us say here the requirement is to look at the customers, only those customers whose name starts with S. So what I'll do is create a calculated field. I want starts with S. So I will use the starts with function. There is one function called as starts with, which will return true if the string starts with the substring that you have mentioned. So starts with, and then you see I have to give the string. String is basically the names of all the customers present in the customer name column. And what is it that I wanted to start with? I wanted to start with S. If you're passing numbers in the formula directly, you can send the number like this. If you're passing string, then it has to be enclosed in quotations. Okay, if you're passing string data, it has to be enclosed in quotations. Single or double, it doesn't matter. If you're passing dates, they have to be enclosed between two hash marks. Okay. If you want to write a comment in the formula, you will give two slash marks like this. So numbers are directly given. Strings, when you give something in quotations, Tableau understands that it is string. It will start treating it as a string. If you put something between two hash marks, it will start treating it as a date. If you give two slashes like this, it will treat it as a comment. As a comment. Okay. Now here we are just passing the string information. So directly customer name. What will Tableau do now? It will inspect each and every name that is present in the customer name column. Aaron Bergman, is the name starting with the character S? No. So it will skip and save the result as false. So for the customer Aaron Bergman, the result is going to be false. For Aaron Hawkins, the result is going to be false. So wherever the customer's name does not start with S, it is going to be saved as false. Wherever the customer name starts with S, that is where it will be saved as true. Okay, that is where it will be saved as true. And the result of this calculation therefore is going to be a Boolean value. T/F is an indication that this is a Boolean value. Okay, because the data we have there is true and false. That's all. And Tableau has placed it in the dimensions pane. Why in the dimensions pane? Because we are working on dimensions. We are working on dimensions. And the result is also a dimension. The result is also just a Boolean value, true or false. Therefore, it is in the dimensions pane. Earlier, we were working on measures. Result also is a numerical value, so it went into the measures pane. Now, this I will take to the filter shelf and I'll say that I want to see only where the data is true. Okay. Now, once I do that, you see I'm getting the list of all those customers whose name is starting with S, where the condition is true. Clear? That is string manipulation. Now earlier, I think Ibrahim, you have asked me which one would be correct, the first one or the second. First one will be correct in this case. First one will be correct in this case. I just told you that you can also do it row level wherever, if you come across a requirement, you can do that. So you first perform the computation, then the aggregation. String manipulation we have seen. Now let us look at date. Now here the requirement given to us is to compute the difference between the order date and ship date in number of days. Now we know that different orders have been placed by customers. Every order is placed on a certain day, right? When it is placed, the day when the order is placed is recorded in the order date field. Now this order date field, you can notice that it is rolled up at year level. Let us go and make it exact date. When you change date to exact date to see the exact date, Tableau will turn that into a continuous field and make it a green colored pill. This happens automatically. Okay, Tableau will make it a green colored pill by turning it into a continuous field, which happens automatically. And whenever you use your date granularity as exact date, the marks card will give you the mark type as Gantt bar. You can see here, mark type is Gantt bar. Okay. Now you have to go and make it discrete. Change it back to discrete. Go there and change it back to discrete. All right. So now you can see the exact date as is. That is one of the methods in which you can get exact date. Okay. Now let us look at the ship date. Again, now ship date is also a date field. So that is also rolled up at year level. You can either follow the same procedure of making it an exact date and then converting it to discrete to see the exact date as is, or you can go to more, anywhere you can go to more, and you can customize the date. So when you go to more and choose to custom, here choose the granularity. I want to show everything, month, day and year, everything. So I will get the month and the day and the year. And what will be the format of the date? Whatever is the date format that you set up, the default date format, whatever you have taken, it will come. Automatically Tableau has taken this. I will change it like this. Okay, so if I change it like this, what happens? If the date format changes, then why is it 1 second? Okay, I think we can put ship date elsewhere. Okay, when we make it exact date, okay, and then we change it to discrete, that is when it will follow the format that you have given. It will follow the format that you have given. But in this case, what is happening? We are specifically telling month, day, and year, right? So it is showing you the month and the day and the year. But here, if you have to change, I think this is something we can't do here. Okay, so we know when the orders have been placed, which is in the order date field. We know when the order is being shipped out to the customer in the ship date field. Now we need to compute the difference between these two dates and try to understand how many days is it taking for an order that got placed to be shipped to the customer. How many days is it taking? Okay, so we have to compute the difference between these two dates in number of days. We have to express the difference. We have to compute the difference and express it in number of days. So we will create a calculated field to get the number of days to ship a product that is ordered. And I will use the date difference function here. Date difference function will give you the difference between the start date and the end date, where the start date is subtracted from the end date in the units that you specify here. So date part should be day. We want the difference in number of days, right? So we have to give date part as day. Start date is there in the order date field. End date is there in the ship date field when it is shipped out. Okay. Now this date part is something that you will find in most of the date functions. It can take anything, any date unit, like you can get the value in number of years, or you can get in number of months, you can get it number of quarters. Okay, you can get in days, you can get in hours, you can get in minutes, you can get in seconds, so on and so forth, and few more combinations are there. Okay, but these are the most frequently used ones. We are trying to get the difference in number of days. So I'm using date part as day. Now date part is case sensitive and it has to be enclosed in quotations. When I do this, you see it has gone into the measures pane because we are doing some action, right? We are doing subtraction. We are subtracting the start date from the end date. So subtraction is happening. Because subtraction is happening, it is a mathematical operation there. So Tableau has taken that to the dimensions measures pane. Now when it brings to the measures pane, what happens if I take it to the text shelf? It will get aggregated. Sum of number of days to ship, it's getting aggregated. Because it is getting aggregated, I'm having a little problem in a few places here. So you see 7th, 13th minus 7th, 6 days, perfectly fine. But 12th of July minus 8th of July is giving you 8 days when it should be giving you only 4 days. 15th of April minus 8th of April is giving you 14 days when it should be giving you only 7 days. Here, 4 days is the difference, but it is giving 16 days. So what is going on here? What is going on here is it is getting aggregated, meaning now observe the order ID. The first order ID is a unique record, only one record. So Tableau took that order ID, computed the difference between order and ship date, and gave you the number of days as 6. But what is happening in the next order is 4 and 4. What is happening is it is basically two products. In that order, two products were ordered. That order ID comprises of two different products which have been ordered. Both of them obviously are placed on the same day and shipped out on the same day. So the difference is 4 for the first record and 4 on the second record. So 4 plus 4, it is giving you 8 here. But would that be correct? That would not be correct, right? All of you facing any issue? Any? It's fine with y'all. Okay, then Suresh, maybe you will have to log off and log back and try check the connection at your end. Okay. Okay, Ganesh. All right. So you all understood the concept, right? Why it is getting aggregated, you understood, because we have used a mathematical operation, subtraction. Because it is subtraction, Tableau has put it in the measures pane, and when something becomes a measure, what happens? It gets aggregated. When it gets aggregated, we are looking at the aggregated result. Okay, so how do we solve this problem? Is either you go and change the aggregation to average, which is meaningful in this case, okay, or you don't even do that. We know that we don't want this to be a measure. We don't want to aggregate it. We just want to see the values present in it. So you can actually make it a dimension. You can actually drag and drop it in the dimensions pane. It becomes a dimension, and now this you use on the text shelf. You can see the difference in number of days. Now no problem. Okay, if you think your data need not be aggregated, it can be a dimension because you want to see the values present in that field. You can always move it over there and job done. So that is another thing. Now let us look at a logical statement. Okay, let us say for different subcategories, I am looking at the average discount. Okay, I'm looking at average discount. Okay, now if the average discount is less than zero point 0.1, I want to say that the average discount is very low. If the average discount is greater than 0.3, I want to say we are giving very high average discount. Everything in between is middle of the pack. Okay, so how can I classify these subcategories into three types depending on the average discount being given to them? So I will go to the analysis menu, choose the option to create a calculated field. I want to compute. I want to basically segregate them into three types depending on their average discount. So I'll call this conditional formatting. You can also call it spotlighting. Uh, and what we will write is if the average discount, if the average discount is greater than No, Jagannath. If you remove aggregate measures in the previous examples, uh, everything will get disaggregated. Oh yeah, in the previous example where we are looking at dates, right? Order ID and date. There you can disaggregate it. It will not cause any problem. You can remove aggregate measures from analysis. Yes, correct. Okay, greater than 0.3, then I will call it high discount being given here. Else, if otherwise, I have one more condition to test. Average discount is less than 0.1, then I'll call it low discount. Else, for everything else means in between zero point 0.1 to 0.3, we'll say moderate. Okay, so very simple logical statement here. And this statement, I'm going to use it on the color shelf. Now, why did Tableau put that in the dimensions pane? We are just trying to categorize the subcategories depending on their average discount into three types: high discount subcategories, medium discount subcategories, low discount subcategories. Why did it, though the result of the calculation was ABC, string data, put it in the dimensions pane? No, it is not Boolean, it is string data. No, either you call something high discount or low discount or average discount, but we are classifying it based on a measure value. Though the result of the expression is string and row it is discrete, that we will get end of the day. Blue colored pill means discrete. Either it is high discount or it is low discount or it is moderate discount. It cannot be in between. So clearly distinct values are there. It is discrete. So the color of the pill is blue, but it went in the measures pane because we have come to this conclusion by analyzing a measure. We have come to the conclusion of which subcategory should go under which type depending on the measure value. So it has taken it here. Even if you take it to the dimensions pane in this case, it would actually not cause any problem. Anyway, okay, we'll leave it here because it's not giving us the option. So as long as it is blue, we don't have any problem. Okay. So here you can also double click on that and you can edit the colors. You can edit the colors. High discount, let us give it green. Low discount, let us give it red. Moderate, let us give it gray. Okay, job done. This is how you classify it. That is a logical statement that we have seen. Okay, now with this base understanding of how to write calculations, etc., let us proceed further. We'll share the first formula with you all on the chat. Just anybody who needs it for reference. Numeric, we saw this example of profit ratio. Under string, we have seen this example where we are looking at for customers whose name is starting with S. Under date manipulation, we have looked at an example that is giving us the number of days taken to ship a product. Okay, and then finally under logical, we have looked at a statement, logical statement like this. All right, I sent everything on the chat. Now let us see what we have. Find out the sales made by Global Superstore after removing the shipping cost from the ship modes. Try this out, please. Connect to Global Superstore and you have to find out the sales after removing shipping cost from it. So basically you should do sales minus shipping cost. Okay, try it out. I'll be back in a minute. You can try it meanwhile. Okay, I hope you're able to do this. So what will you do? You will get connected to a new data source, which is global superstore. And then use the orders worksheet. What is it that we have to see? For different ship modes. So we have to build our chart at ship mode level of detail. We know that there is some sales associated with it. We know there is some shipping cost associated with every ship mode. We need to compute sales minus shipping cost. Okay, we need to compute the sales information after removing shipping cost from it. So sales minus shipping cost is what we are interested in. So we will do sum of sales minus sum of shipping cost. Okay, sum of sales minus sum of shipping cost. Now this information, you can take it and place it there. Actually, in the final report, we only need this much, this data. Okay, you don't need sales information. Uh, you don't need sales information. You don't need shipping cost information, not required. Only thing that you need is sales minus shipping cost. Okay, so we are working on aggregated data, right? We are taking sum of sales, which is this single value, and doing subtracting sum of shipping cost, which is this single value, giving us the result, which is a single value which cannot be further aggregated. So AGG. AGG means we have got only a single number as a result of the aggregation that we have performed. So it cannot be further aggregated. Even if you aggregate it, it's meaningless. Okay, so this is the solution for the first one, where you don't need to show sales, you don't need to show shipping costs. This is the report that we are supposed to create. All right, so I hope it's clear. Let's proceed to the next example. Very simple example, actually. Next, find out the profit coming from the customers whose first name is Brian. Try it out, please. I'll give you all a minute here and then I'll tell you the solution. Try it out. Find out the customers, profit coming from those customers whose first name is Brian. Try it out. Find out the profit coming from the customers whose first name is Brian. So what will we do? Similar lines of what we did earlier. So let's go to sample superstore, look at the customers and the profit that we are getting from each of those customers. Okay, now we want to see only the profits from those customers whose first name is Brian. So what will we do? We will take will not filter, we have to do it through calculation. So we'll create a calculated field for first name Brian. Okay, so starts with function only you can use. Starts with what? The customer name that starts with Brian has the substring. First name means it will start with that, right? In superstore it is first name, followed by that we have last name. So we can directly go with this starts with function and click on OK. So that will be your formula. Now what will happen? You have to take that result, because what happens if the condition is satisfied, the result is going to be true. If the condition is not satisfied, the result is going to be false. So Claire, the name is not starting with Brian. False. Sorry. Yeah, Ibrahim, any question here?
No, I just lost that. Can you repeat that particular one?
Which one? This one? This one?
Yeah, got it.
So the result of this calculation will be true only for those customers whose name is Brian. Okay, you see here. For the other customers whose first name is not going to start with Brian, you can see that the result is false. Till here true, and from here on it is false. So what do we need? Only true. Therefore, we will take this to the filter shelf and select true and click on OK. So the list gets updated with the only those customers that meet the condition. Okay, right. So this is about the second one. Date. Find out the difference in order date and ship date to know the average number of days taken to ship an order that is placed. So you just, this is the same thing that we have on the first slide. Can you try it out? Whatever I showed you all, and the formula also I sent you all, date calculation. Same thing you have to do here. Try it out and give me a confirmation once it is done. We'll proceed to the next example. I sent you the formula on the chat already for this. I hope you're all able to do it. It's just a replication of what we did here. Was explaining you about the date functions. So you take different order IDs are there, different order dates are there. They are placed, shipped out on different ship dates. We just want to compute the difference between the two dates. So we have created the calculated field, which is giving us the difference. But the requirement here is to see the average number of days taken to ship an order. So we will not make it discrete. You will get a measure and you will leave it as a measure only. But you will use the aggregation here as average, which means when you are using it on the graph, change the aggregation to average. So we're getting the difference between two dates and number of days. That is what you will have to do. Now functions, Tableau functions and calculations is a never-ending topic actually. There are so many things to cover. So what we did is there were 3 webinars conducted on Tableau functions alone. So in one webinar, we have looked at all numerical and string functions. There is one webinar where all the date functions have been taken care of. I mean, they have been explained in detail, each and every date function. And there's one webinar where we have looked at logical functions, aggregate functions, and type conversion functions. Okay, so whenever you have time, you can log into AI Spry, you can check the Tableau folder for webinars. And there are 3 webinars dedicated only to functions. And last week, there's a webinar that was conducted on quick table calculations, which we will anyway cover now. So that is another thing. All right. So functions, you might want to go through those recordings also. So I hope all of you are okay with this example with respect to date calculations. Now we will proceed to the next example. Where we have a few things to solve under logical calculations. Okay. So first thing is you have to create a calculated field to categorize the sales over here into different types: high sales, moderate sales, and low sales. Just like we did high discount, moderate discount, and low discount, same thing. So what you do is above 250,000, make it high discount. Below 50,000, make it low discount. Please write a logical statement here. I'll give you all 2 minutes, after which we will proceed. Please solve this. Take 2 minutes time. Above 250K, high discount. Below 50K, low discount. Anything in between is moderate. Why am I saying discount? Sorry, sales. Above 250K is sales. Below 50K is low sales. And in between is moderate sales. So you can also call this as sales spotlighting. You can call it as conditional formatting. Please do this. Build that logical statement. What should it be? Should it be sales or just sales or sum of sales? See, if you say just sales, then whatever you write in the formula, it will compare it with the data in your sales column. It is never going to be more, it'll individual record, nothing will be above 550,000 at least. So everything will go under low sales if you do just sales. Okay, so it should be sum of sales here. Sum of sales, where the summation of the sales is computed first, depending on how you build your chart, right? Means if you're building a chart for different subcategories, Tableau is going to give you the sales for different subcategories, sum of sales. So we want to work on these values here, these sum of sales values. So you have to use sum of sales in the formula, which means data is supposed to be aggregated first, then it has to be manipulated in the formula. Then it has to be used in the formula. So first aggregation. So you have to use sum of sales. That aggregation that you write in the formula, sum of sales you write in the formula, will be at the level of detail on the chart. All the calculations at the level of detail on the chart. Okay. Are you all able to do this? Any problem, any difficulty here? So you will say if the sum of sales is greater than 250,000, then we will call it as high sales. Otherwise, we'll check the sum of sales. If it is less than 50,000, then we will call it as low sales. Otherwise, we will say moderate sales and end. This is how you will have to build your formula, and that formula will go in the dimensions pane, sorry, measures pane, because we are checking the sum of sales value and deciding what it is, and then you will take it to the color shelf. Yeah, I hope you're all okay with this formula and you were all able to solve the requirement. Let us proceed to the next requirement. Very interesting again. All of you will have to get connected to coffee chain data source and look at this. We are supposed to segregate these products being sold by the coffee chain business into two categories: tea related products and coffee related products. So we have to segregate the products into two types: tea and coffee. Depending on the product type, you can do it, because if you go at product level, the thing is we have too many conditions to capture, right? Too many products to capture. Like for example, let me get connected to coffee chain. I'll use Excel. So what happens here is product type, and let us look at the products. So we have to classify these products into tea and coffee, but each of those products already belong to a product type. Coffee and espresso, they are basically coffee. Herbal tea and tea are tea. So rather than categorizing based on this information, where you have 7 conditions, 7 different coffee and 6 different tea related products to handle, you can just handle this much. Okay, so try to build a statement, case statement, using product type. Evaluate the product type. When the product type is coffee, then you should call it coffee. When the product type is espresso, then also you should call it coffee. When the product type is herbal tea, you will call it tea. And when the product type is tea, obviously you'll call it tea. And ultimately in your chart, you will have only the list of products and whatever is their profit, let's say. And you want to color the bars in such a way that the colors, the bars will be, you will have overall 2 colors, one color representing coffee related products, other color representing tea related products. Try it out, please. Use the case statement here. Case syntax. We have seen case statement with background images, right? Same syntax. So you will create a calculated field. See, when you have this doubt, what should be the syntax? What should you do? Check here. And you see, you get the syntax. Okay. Even for a new person, it should not be a problem. You check for the function here and you get the syntax here. So what are we trying to do? Case statement we are using to evaluate the product type. Okay. When the product type is T, when the value in that product type field is T, then we want to call it T only. When the value in that product type field is herbal tea, then we want to call it tea only. And when the value in that product type field is coffee, then we want to call it coffee only. Then we want to call it coffee. And when the value over there is espresso, then we want to call it coffee. Getting it? You can also give else for a generic condition, but here we have captured all the 4 options, right? So you can leave it like that. Okay, all of you please build this formula. Okay, I will send this formula on the chat just for your reference. You can take it and you can actually paste that formula in the calculation editor if you're not able to write it. Okay, after this what you will do is click on OK. Once you click on OK, now you see, where did it go? It went into the dimensions pane. Why into the dimensions pane? Because we are checking the values present in the dimension member. Is it tea or herbal tea or coffee or espresso? We are checking the values in a dimension member product type. Based on that, we are putting it into 2 different buckets. Okay, so it has gone into the dimensions pane. We have not used any mathematical operator. We have not used any measure in that formula. The result also is not a measure or something that can be aggregated. So it is all dimension related. So it went into the dimensions pane. Okay, now this we will bring to the color shelf. You will see tea in one color and coffee in another color now. Tea related in one color and coffee related, they have come up in another color. Okay. All right. So I hope all of you are okay with this example. Let's proceed to the next one. Zn is a very interesting logical function that will replace null data with zeros. So if you think the result of the calculation could result in null, if you could get a null data or something is null in your database, you can convert it into zero by using Zn. For this, I will give you an example. Okay, I'll get connected to a data source which I built only for this example to explain Zn. Now here in this data source, we have data for 4 departments, and there is one department which does not have any data entered there. Okay, which if it is blank, it means it is null, right? When data is not entered, it is blank. It is blank meaning it is null. Null means what happens? When you create your report also, it will turn out blank. It will be blank only. You see, it's left blank. So if you want to replace this blank with 0, you just have to wrap that function around Zn. So I'll say Zn of sales. Zn of profit, sorry, not sales. Finish. I'm doing Zn of profit. So now the result of this calculation Zn, if I use it in the text table, you will see it's going to show me 0 wherever there was null data. Getting it? So null data is replaced with 0 by wrapping that field containing null data in Zn. Or if you think when you write a formula, if you think this formula could give me a null result, the result for this calculation could be null. There's a chance. It's not really possible that you would get null data, but if at all you think something, you're working with null data, if you're working with a column, if you're working with a column which has a lot of null values in it, okay, and when you use a column with a lot of blank or null values in your formula, it's going to result in null result, means nothing, blank. Then instead of showing the result as null, you can show it as 0 by simply wrapping that expression in Zn. That is the purpose of Zn. Very interesting and very useful expression. Zn, very useful function that will replace null with 0, as you can see on the graph. Next is ad hoc calculations. Ad hoc calculations mean simple. They are also called as inline editing. It is also called as inline editing. Like let us say I have a report showing me sales. Now I want to edit the sales. I don't want to see sum of sales. I want average sales. I'll double click on that. When I double click on the pill becomes editable. It becomes editable. Okay. And now instead of sum, I will make it average. So very quickly I have converted sum of sales into average of sales. Now let us say along with sum of sales, I want to see average sales. So I'll just double click on the empty blank space here. I will get a editable blank pill where I can write even a formula, but here I'm just using an aggregation that I want sum of sales. Getting it? So you can get that on the columns shelf, you can get an empty pill on the row shelf by double clicking, even on the marks card by doing a double click. So it's just on the fly. If you want to test something, a what if scenario you're trying to test, or you want to change the aggregation, even write a formula that will be used only one time in that workbook, and you don't want that to be saved as another field here, then you can just use an ad hoc calculation. Okay. Zn you want to see again? All right. Here. So what I did here is I just took Zn and I put it, I used the Zn function and wrapped profit inside it. I put profit inside Zn. Okay, run. All right. So any questions on whatever we have discussed so far? I request you all to, whenever you get a little time, go through the videos on Tableau functions. You get a lot of explanation on almost many different functions that are available in Tableau. String, aggregate, date, logic, type conversion, etc. Try out an ad hoc calculation also, and then once you are done with it, we will take a break. Try out an ad hoc calculation. No, Ibrahim, if you're using Tableau Public, then the only place where you can save your workbook is the Tableau Public server. You have to publish it there. There is no other way of saving the work. That is the reason why it is not used in a corporate environment, you know. Though it is at par with Tableau Desktop, why we don't use in a corporate environment is we don't have an option to do a local save or save it in a secure manner. The only place where you get to save it is Tableau Public Gallery, which is an open forum. Getting it? Okay, I don't see any further questions on calculations. Yeah, it's transparent to all. Yes, yes. Anybody can go to your account and anybody can download your workbooks. Okay, they cannot delete or edit, but they can download a copy of your workbook onto their own machine and start working on their own Tableau desktop tool. So there's no security involved. Okay. All right, let's take a break for 10 minutes here. After the break, we will continue with our discussion. See you in 10 minutes. Thank you. Hello, everyone. Hope you're all here. So we'll continue with our discussion. Okay. So we have seen a few examples on calculations. Now we are going to proceed to the next concept, which is quick table calculations. Okay. Now, for each and every requirement that we face, we don't have to go and write a formula because there are certain requirements which are taken care of, certain calculations which are taken care of by Tableau people itself. Like if you want to compute the running total, then you can use the calculation which is pre-written in Tableau called as quick table calculation. If you want to get the difference or percent of total, rank, percentile, moving average, YTD total. YTD is year to date, compound growth rate, year over year growth rate, year to date growth. So if you have to do any of these functions or any of these activities, you don't have to sit and write a formula for that. Tableau will Tableau has already written the formula, and that formula is called as a quick table calculation. Okay, now how do we make use of quick table calculations? Let us see. To understand any calculation in Tableau, just there are two things that we need to understand: a concept called as partitioning and a concept called as addressing. Once we know what is partitioning and what is addressing, everything else will automatically fall in place and we will get to know how to do everything else. Okay. So let us understand the concept of partitioning and addressing and also understand the concept of quick table calculations in Tableau. So what I will do is, now let's say this is something that we have learned already, something that I have mentioned multiple times, but I will give you the complete understanding one more time. Suppose I take profit and try to build a chart using the profit information. What is Tableau going to do? It is definitely not going to show us each and every value that is present in the profit column. Right? It is not going to show us each and every value present in the profit column. Rather, it is going to aggregate profit and show us the sum of profit. So what did it do? It summed up the entire information present in the profit column. Summation of the profit is coming up to be so and so value, which we are able to see on the canvas, on the graph. Why did this happen? Because measures in Tableau are always aggregated based on some default aggregation property, and that is why this has happened. We know that. Okay, now what will happen when you take a dimension to the chart now? Let's say, for example, category. Immediately, Tableau is going to show us the sum of profit computed per member in the category dimension. Agreed? Did we go and manipulate the sum of profit? No. All we did is we brought category onto the canvas. Immediately, Tableau has partitioned the data at category level of detail. Furniture is a partition. So what is Tableau doing? It is now looking at the data per partition. So furniture is one partition. When I look at the data for furniture category, okay, let me just hide these things which are not required. So for furniture category, it is computing the summation of the data in the profit column and telling us the profit is 18,451. Then office supplies is another partition. We have bucketed the data basically. You're bucketing the data into different types, different buckets you're taking it. Furniture is one bucket or partition. Office supplies is another bucket or partition. So when I look at data in office supplies, summation of the data in the profit column for office supplies is this 122,490.8, 122,491. Then technology is another partition or another bucket, right? Data corresponding to technology, which is another bucket or another partition. Summation of the values in the profit column for technology is so and so value 145,454, rounded off to 455. You at any point, if you have any doubt, let me know. Okay. So basically, we know that whenever we use a dimension, Tableau is going to granularize the data by the dimension that we use, which is called as partitioning. Now, in addition to category, suppose I take the date field, what will happen? Further, it is going to partition the data. Now, in technology, it is again subdividing technology into different years. Further, my data is becoming more granular. So when I use more dimensions, what is happening? Data is becoming more granular. More dimension, we are at a very lower level of detail, you can say. We are going at a very granular level of detail. Okay. So now in technology, now again, if we look at data for different years. Okay, let 2011. Under technology, when I look at only 2011 transactions, summation of the data in the profit column is so much 21,492.8, 21,493. Okay, you are, I hope, able to understand what is going on. Now, let us say my requirement is to represent this information as percent of total, as percentages. How do you compute a percentage? Now let us say I am the manager of bookcases, subcategory bookcases. I am the manager of subcategory bookcases. That is one department, bookcases, and I am the manager. So I just want to look at the performance of bookcases across different years, and I want to express this as percent of total. Okay, I want to express it as percentage. So I'll show the row grand totals. This is the overall total of bookcases. It is actually a loss. Okay, it's actually a loss. And then what is the contribution of each member towards that overall loss? Okay, or let's not say bookcases. Let it, I'll change. I want to be the manager of chairs. It's giving profits. I'm happier here. Okay, so I'm the manager of chairs. This is the total profit that I have obtained from the chairs subcategory. Now I want to see what percentage of these profits are coming from which year. So how would you compute the percentage if you have to? Total profit there is 26,590 divided by the profit from 2011, for example, 6955. So if I have to represent it as percentage, I have to multiply it with 100. Did I do the right? Yeah. So we have to do it like that. Now what I will do is I will simply, instead of writing a formula, I don't have to write a formula in Tableau for percent of total because it is available as a quick table calculation over there. I made wrong, no? Yeah, I was also wondering what I did. Yeah. So what is this out of this? This is my total profit. This is my 100 marks, of which I obtained so and so marks here. Let's say 20 marks here. So 20 divided by 100 will be my percentage. So the total 26,590. This whole thing you multiply by 100, you will get the percentage. Okay. Now, to do this, we don't have to write a formula in Tableau because uh, we have an inbuilt calculation for computing the percentages. How do you access it? Is these quick table calculations can be applied on numerical data. So I'll go there, click on the drop down icon, go to quick table calculation and access percent of total. Okay, once I select percent of total, now you see percentage is getting computed. This is 26, what we obtained here, 26. Okay, are you all with me here? Why is it computing at row level? How does it know I am the manager of chairs, so I'm focused on at row level data? That is because by default, all the calculations which happen in Tableau will go table across. By default, all the calculations in Tableau are performed table across. Table across means at row level. Just remember, table across means row level they will be performed. They will be performed at row level. So every row, the data is summing up to be 100%, and the contribution of each member towards that 100% is what we are seeing. All right. Appliances, art, everything. Now let's say my management is very happy with my performance in chairs, and they said this person is doing well, let me give her a promotion. They said, fine, you're doing well, I will give you a promotion. You take care of the entire data in 2011. I think this is not sensible, like 2011. Maybe region, you think of this. I think I will actually replace it with region. Okay, let's say they decided to give me a promotion and they said, you're doing really well. So we want to increase your responsibility. Rather than taking care of just chairs, take care of the entire central region. That is a very big promotion. I'm taking care of entire region altogether. Now, accordingly, I want everything to be recomputed. Right? I'm no longer interested in chairs or bookcases or furnishings or tables, their performance. No, I'm interested in their performance in central region. I'm interested in how is bookcases performing in central region. How is chairs performing in central region? How is furnishings performing in central region? How is phones performing in central region? So my focus is on the data that is in that column, central region. So what should I do now? I want Tableau to take the data in that column into account. Think of that to be 100%. The overall profit from central region should be considered to be 100%. And the contribution of each member towards the overall profit of central region is my focus. All right. So if I want the computation to happen table down at column level, I have to change compute using accordingly to table down. Table down means each column sums up to be 100%. Okay, and the contribution of each member in that column towards the 100% we are seeing. So when I inspect central region data, I notice that I'm getting very high profits from where? Copiers, phones. Okay, now accessories and paper is also good. Chairs is good. Most of them are giving me a loss in central region. Clear? Table across means row level it will perform. Table down means column level data is taken into account and percentages are computed. Now let's say after my management made me the manager of central region and I'm looking at this data and focusing on these values, I became a little complacent. I'm like, okay, people have noticed me. They know that I perform well. So now I'll take rest. What happens then? People will notice that also. 100 days you have performed well and one day you don't perform well. That goes into their, you know, it definitely goes into their notice somehow. So they said, no, no, you're not doing well. We'll reduce the workload for you. You're not able to handle so much. So very nicely they say we'll reduce the workload for you and we'll make you the manager of just furniture. Just furniture. So what are they doing now? They actually gave me a demotion. Right? They said, no, no, you have become complacent. They will not tell all that. They will just tell, start handling only furniture. Now they told me this. Now what is my focus? I have to perform well now. So what is my focus? I have to focus on furniture and the performance of different subcategories across different regions in furniture. So I want everything to be computed by at furniture level of detail now. You're getting the scenario, right? Now I want all the values here reflecting their contribution in furniture category. That much only I'm interested. So furniture is a pane. Furniture is a pane, right? So I will go here and I will change compute using pane level. Pane. So this pane will sum up to be 100%. Let me show you the subtotals now. You see how the furniture pane is 100%, how office supplies is 100%, how technology is 100%. Getting it? Depending on the question that you're trying to answer, you have to choose compute using. It could be row level, it could be column level, it could be pane level also. All right. Now they like my performance. I did well. It was like a wake up call and I did well. I said, okay, I should wake up and do well in at least now. So I did well in furniture. Now they're very happy again. They said, okay, you are doing really well. Let us make you the manager of Superstore itself. Take care of all the regions, all the categories, everything.
Now, what is my focus? The entire data in that table is my focus. Entire data in that table is my focus. So I want to see the percentages also computed at table level. Table level. So the overall grand total is 100%. And these are the percentage contribution of each member towards the 100% contribution of the business happening in the business. And these are the subtotals. So if 100% is my overall profit, 6% of that profit is coming from furniture, 42 from office supplies, 50 from technology, 13% from central region, 32% from east region, south region and west region. Getting it? And then the subcategories also, we can see each cell and the contribution of each cell towards the 100% I can see. Is this concept clear? Partitioning and addressing. Partitioning is about how you granularize your data. Addressing is the direction in which you compute, okay, the direction your calculation is taking. That could be table across means row level, table down means column level, pane, again pane across, pane down also possible, then at table level. Or if none of these options are helping, you can also go at specific dimensions level. Okay. Subtotal, anytime you want totals, you have to go to analysis, go to totals, and then you have to turn on whatever you want to see. Subtotals option will become active only if there is a pane in your table. Means that subdivisions are there, then subtotal will come, right? Okay. Is it clear, everybody? Partitioning and addressing and percent of total. Other options? Everything we covered, no? We covered table across, table down, table. Pane down means it will go only pane level. This much. Okay, pane down means it will go this much level. So this is one pane, no? Furniture. In that down. So the column itself is getting broken into smaller units. Pane down. Then you can go at pane level that we saw anyway, that whole pane it was taking rather than just a column in the pane, the whole pane. Then you can go at cell level. Everything will be 100%. It's like I'm comparing myself with me only. Then to me, I'm always 100% good, right? Cell level. Then you can go at specific dimensions level. Specific dimensions level means category level. Category means what will happen? It will be equivalent to, one second. Let's go back to table across. Go at category level. Okay. When you're going at category level, that this is fine. So for each category you're computing. Each category's contribution towards the overall. Okay. So it's as good as saying cell level. Then you can go at region level. For each region it is computing now. Then you can go at subcategory level. Okay. So depending on what you're trying to answer, what is it that you're trying to generate ultimately from that report, you can choose options that are available here. None of the options are helping you. You can go at specific dimensions level also and edit it. Okay. Right. So with this understanding, let us look at the other quick table calculations. I'll just take that data into an Excel and then we'll discuss. Okay. Now, did it come into an Excel? Yeah, my data is there. So this is what basically the sales information that we are looking at. I will apply a quick table calculation on this data. I will apply a quick table calculation called as year over year growth. Okay, next quick table calculation is year over year growth. Now, when you say year over year growth, Tableau has given us the year over year growth information. Let me just copy that, paste it in an Excel, and I will tell you how it is computed. YOY growth. Year over year growth means from 1 year to the next year, what is the kind of growth that has happened in sales in this case. So from 2011 to 2012, it is actually not positive. It's not an increase, it's actually a decrease that we are looking at. So the growth percentage is negative. As you can see here, it is minus 7.52. So how is year over year growth computed is, it's the current year data minus the previous year data divided by the previous year data. Whole thing you can multiply with 100 to express it in a percentage format. Okay, so that will give you minus 7.52, you can say. So I'm repeating it. What is it? The current year data, let us say 2013, minus the previous year data 2012 divided by the previous year data, the whole thing multiplied by 100. This is the formula which Tableau is internally applying in order to compute the year over year growth. Year over year growth. Okay. Now 2011, we have nothing to compare it again. So that is all blank. After you have applied a quick table calculation, you will see the pill will have a triangle icon on it at the end, meaning we have applied some quick table calculation over here. Suppose you want to save it as a calculated field and use that data in some other report. You can just drag it into the data pane, measures pane, and Tableau will create a calculation for you. Okay, so I will call this as YOY growth, year over year growth. If you want further, you can go and even inspect the formula by doing an edit and check what Tableau did there. Okay, you can also go and check what kind of results have been generated here by Tableau. Okay, now this whole thing, suppose I wrap in ZN. You see here, wherever there was null, we're getting zeros. So if the result of a calculation is going to be null for whatever reason, and you want to show that as zero rather than leaving it as a blank thing, you just wrap it in ZN. All right. Okay. So the next quick table calculation we will see is let's do year to date total, YTD total. This is YTD total. Year over year growth. Which part? Saving it as a calculated field. You want me to repeat that one? So whenever you create a you apply a quick table calculation, you will see triangle icon, and that will, when you drag and drop it in your data pane, in your measures pane specifically, Tableau will save it as a calculated field and it will give it some default name. Here you can change that name. YTD total, this is. Getting it? Okay. So now let us examine how Tableau computed YTD total. Now what is YTD total? It is basically the summation of the values from the beginning of the year to the end of the year, cumulative total. Okay, it is nothing but running total that restarts every year. Running total that restarts every year. Now, what is running total? Now, let us say I have some profit information. Okay. Something like this. This is from Jan, this is Feb, this is March, this is again Jan, Feb, March, and this is for 2010, and this is 2011. Okay, this is profit data. Now I want to compute running total or running sum. Running total is nothing but cumulative total. It's also called as cumulative total. What are we getting here as running total or cumulative total? First data point will be 10 only. Second will be the summation of these two values, 10 plus 20, that will give us 30. Third is going to be the summation of these three values, 10 plus 20 plus 30. All the three, when I sum up, I get 60. Here it is going to be summation of this entire data, which will make it 65. Here it is summation of all this data, which will make it 75. And here it is the summation of all these values, which will make it 95. So that is running total. Most of you would be knowing it. I'm just telling you in case anybody who does not know, they will note it. Okay. So that is running total. It is cumulative total, like the number of COVID cases. On a daily basis or monthly basis, certain cases we are getting. But total number of cases till date is nothing but your running total. From the beginning, when the first case was recognized to till date, whatever. Everything is cumulative, right? You just aggregate everything. And the cumulative total is what we see. That big scary number is the cumulative total, not per day cases. Correct. Now, if I have to compute YTD, year to date, which is called as year to date total on this data, it is nothing but running total only. It is nothing but running total only. So here it will be 10. Here it will be summation of these two values, that will make it 30. Here it will be summation of these three values, which will make it 60. Here it's going to be the summation of these four values. No. Okay. No, because year to date means it works only on the data in that year. So when a new year is encountered, here it will restart. So again, here it will be 5. Here it will be summation of these two values from the beginning of the year to till date, whatever. That is 15. Then here it will be beginning of the year to till here. So that will make it 35. Is it clear, everybody? What is running total and what is year to date total? Okay, now with this basic understanding of what is running total, what is year to date total? Now let us see what Tableau did over here for year to date total. So this is quarter 1 of the 2011, quarter 1 of 2011, same thing. The moment I come to quarter 2, this is cumulative total, right? So this is going to be the summation of the sales in quarter 1 and quarter 2 together. Quarter 1 sales plus quarter 2 sales together is giving you so and so value. Then when I come to quarter 3, these three summation of the sales from the beginning of the year to quarter 3 is so and so value. Beginning of the year to the end of quarter 4 is so and so value. So that is nothing but the overall sales that happened in 2011, how we have improved our sales, and this is the final sales for that year. Okay, so that is your year to date total, YTD total. Then next quick table calculation we will apply on this. Let me just remove this and I'll apply another quick table calculation on sales called as YTD growth, year to date growth. YTD growth is computed just the way YOY growth is computed, similar to your YOY growth. YTD growth formula is the same. The only thing is YTD growth is computed by taking YTD total into account. Year over year growth is computed on the actual sales data here. YTD growth is computed on YTD total. So here you see the first column, first row and the first row here. Both are the same. That is why this and this same. Why? Because we are using the same data. But when it comes to quarter 2, that is where things change. This is the sales which happened only in quarter 2, whereas this is the cumulative sales, quarter 1 plus quarter 2. Okay, when I look at quarter 1 and then quarter 2 sales combined together over here, there is a decrease. Even here, you see there is a decrease in the cumulative sales until quarter 2. So that is minus 1.87. How is it computed? Same formula. Okay, the current year sales minus the previous year sales divided by the previous year sales, whole thing multiplied by 100 if you do, minus 1.87. Okay, so how is it computed? The formula is the same. The basic data on which the formula is applied will change. YTD growth is computed on YTD total. Year over year growth is computed on the actual sales value or the profit value, whatever you're trying to compute. Okay, now let's say I'm looking at yearly sales. Okay, now I would like to compute something called as the compound annual growth rate. This is the sales value, and I am interested in computing something called as the compound growth rate or compound annual growth rate. So again, I don't have to write a formula because it is present. Compound growth rate is there as a quick table calculation. So I will select compound growth rate, and that is the compound growth rate Tableau computed and gave us the answer. Now, how is it computing the compound growth rate? Let us see. Compound annual growth rate, it is called as. So the formula that is used for compound annual growth rate is ending value divided by the beginning value raised to the power of 1 by number of years, whole thing minus 1. V final is the ending value divided by the beginning value raised to the power of 1 by number of units in time period minus 1. Whole thing minus 1. So if I have to apply that formula, how is it computed here? Ending value divided by the beginning value. This has to be the raised to the power of 1 by n. So since the establishment of the business in 2011, how many additional years have passed? Only 1 year. 2012 has passed, right? Since 2011, I'm comparing 2012 and 2011. So only 1 year has passed. So I have to raise it to the power of 1. And then this whole thing, I'll do a minus 1. Getting it? Now let us compute here. It will become even more clear. Ending value divided by the beginning value, not the previous year. Unlike here, YOY and YTD, it is comparing with respect to the previous year. No, this is ending divided by the beginning, the year of establishment of the business. This whole thing raised to the power of 1 by number of years. So since the year this business was established, how many years have passed? 2012 has passed, 2013 has passed. So 2 years, which means T will be 2. Number of years passed is 2. So I will have to raise it to the power of 1 by 2. 1 by 2 is half. Half means 0.5 I can tell. And whole thing I will do a minus 1. Getting it? 12.10%. So here what will happen? Ending value divided by the beginning value raised to the power of what should I do now here? How many years have passed? 3 years have passed. 2012, 13 and 14. 3 years have passed. So I have to raise it to the power of 1 by 3. 1 by 3. 1 by 3 means let us approximately take as 0.334 will make it. Not 334, anything like that you can make it. Okay, this whole thing minus 1 I have to do, which is giving me 14.87. Getting it? So that is how compound annual growth rate is computed. Then we'll do moving average and stop. Rank also we can do, actually rank will do. Rank and then moving average, and that would cover everything. Difference and percent difference is just simple. You can check you can do it right yourself. Let's say I have created a map. A geographical map showing me the data for different states in the US, and I'm looking at the sales information. Okay, now by looking at the size of the circles, I know that okay, sales of California is good, sales of New York is good, sales of Washington is good, sales of Texas is good, fine. But if I tell you in which position does the state of Illinois stand with respect to sales, will it be easy to answer? I have given you data for 49 states and I'm asking you what is the position of Illinois with respect to sales, or what is the position of Colorado with respect to sales. California, you will tell it has the highest sales, rank 1. But what about the other things? How do you tell that? So what we will do is we will label it with this rank. Sales I will take to the label shelf. Even now I can see the actual sales value, but I cannot really tell what is the position of each member with respect to the other. Which one is doing extremely well, rank 1? Which one is doing very poor, rank 49 with respect to sales? So here what we will do is we will simply go to that sales with the text icon and apply quick table calculation rank. So Tableau is going to give a rank to these states depending on their sales performance. So I can answer Illinois, rank of 7, Colorado, rank of 18. That is the purpose of rank function. It will rank depending on the data. Then next thing we will discuss about is called as moving average or a moving calculation. So a moving calculation is also called as a rolling calculation. What it will do is, now again let me say I have data for different months. Etc. And I have some profit data. Something like this. And I have been asked to perform a moving calculation on this data. When you say moving calculation, you have to specify something called as the window size. Okay, I'll use window size of 3. Window size. Okay, window size of 3 means the frame is fixed. The window frame is fixed by taking 3 values at a time. Now I have to get the moving, let's say moving summation. So these 3 sum up to give me 40. And then the frame is fixed as 3 units. The frame window size is fixed as 3 units. It just moves down or it just rolls down. When it rolls down, next 3 values in the window whose summation is 20. Then it rolls down, next set of values again 20. Then it rolls down, next set of values in the window again 20. Okay, then it rolls down and there is not enough data in that window now. When it rolls down further, there is not enough data. What to do when there is not enough data? There are 2 things we can do in Tableau. We can either go with whatever data is left out and continue the aggregation. And when I go further down, I don't have enough data, but I'll take 10 and do it. But this could sometimes lead to mislead us, because still here we are talking about average of 3 data points, here average of only the summation of 2 data points, and here only 1 data point. It could lead to skewness, or it could basically mislead us. So what we can do, other thing we can do is, when there are not enough values, still here it is fine, but when I don't have enough values in that window for a moving calculation, I will leave it as null. That is another thing that we can do in Tableau. Okay, you can either go ahead with whatever data is there or you make it null. All right, now let's go here. Let's say I'm building a report to show me the sales of Superstore, and this is daily sales, day wise. Now, when I see a daily sales report, it's really difficult to analyze with so many marks and all. It is all cluttered kind of. Right, I really am not able to understand what is this. I cannot understand if there are any underlying patterns that the data is going through, periodical increase and decrease in the sales. I cannot identify any patterns. Okay, so in this case, if you go and perform a moving calculation, let us say I want to get the moving average of the values there. Moving average. Now this is moving average, but how did Tableau, what is the window size? We said that when we say it is a moving calculation, some window size should be fixed. Accordingly, Tableau will compute. Here I'm taking the average. It is computing the average, but taking how much data into account? We don't know. So after you have applied the quick table calculation, you can edit the table calculation. When you edit the table calculation, you can see we are doing a moving calculation. Specifically, we are doing moving sum. And how many data points at a time we are considering? Current value and previous 2 values. Next 0. From the current value, we are taking previous 2 values and next 0. I will increase this. From the current value, take previous 30 values and take next 15 values. So what is the window size here? 30 plus 15, 45 plus the current value 46. When I take so many data points and compute the average, this is my curve. So some little patterns are there. This is called a smoothing effect. Smoothing effect, where we are smoothing out the data and then seeing if there are any hidden patterns. All right. Now you can change that further if you want to. You can also go there and increase the interval further, edit the table calculation, and we can increase it. Let's say another 30 after also. And I did not tell to make null when there are not enough values. So when I don't tell it to make null, it will just go with whatever data is available. That is why here and all it's a little weird. Okay, because it does not have enough data, but it's continuing with whatever data is there. What else we can do? We can make it null. Let us make it null. I'm going to now tell to make it null when there are not enough values. Null when there are not enough values. Now you see it will change. Okay, so certain data, some nulls we are having. Okay, so that is about how you deal with all this part. It has not given you the graph. It's going from 13th February, though we have data from 4th January. Why did it start from 13th February? Because previous 30 values we need. Previous 30 values we need. Why did it stop here at 23rd November when we actually have data till 31st December? Because next 30 values we need. Here next 30 values are missing, so it could not go beyond. Here previous 30 values are missing, so it could not go beyond. Getting it? So like this we can go and create reports. There is no criteria as such. You have to decide what is the best. Depending on the data, you get to decide which interval is giving you the smoothing effect more well. 30 units, 40 units, 60 units, 90 data points, anything you can take. There is no rule as such. Looking at your graph only, you have to take a decision. Whatever is you think is giving you a much smoother effect, you can go with it. Okay, basically it will reveal the underlying patterns, if any. If there are no patterns, they'll not come up, if any. Okay, so here we will stop our discussion on quick table calculations. We have a session on Friday, evening 7 o'clock. Day after tomorrow, evening 7 o'clock, there is a session on quick table calculations where I will do some additional examples. Okay, if you want, you can join that session. And yeah, tomorrow we will do something called as level of detail expressions. The next module is level of detail expressions. Again, by far the most difficult concept in Tableau. So we will do that tomorrow. Okay. And day after tomorrow, we will be having a session on level of detail expressions, after which we will have a 1 hour session of our own where we will do custom charts. Okay. Yeah, that's it from my side. Thank you all. I will see you tomorrow for the next session. If you have any questions, let me know. I'm available.